Okay, ladies and gentlemen, we're going to talk about stuff that, once again, we will talk about the way you're supposed to solve problems and the way you may do it. So, today's lesson, we will talk about the correct way how to solve these are called exponential equations. So, we'll do it both ways for these three problems. So, we'd start with 24 is equal to 3x minus 2. Now the way you're supposed to do these problems is to isolate the x, and in order to do that we have to switch the form to get the x out from the exponent. These were the problems where we did logarithms. This would be log with a small base of 3 of 24, and then on the other side of the equations we would put the x minus 2. And your whole goal is to get the x by itself first. So now we got to add 2 to both sides. So we have log with a base of 3 of 24 plus 2 is equal to x. And at this point we type it in the calculator. So reminder how to type this in the calculator. We press alpha window and we go down to log base, put a 3 here, 24 here, and then we would just get out of here to add 2, and we get 4.893 if we rounded. So that would be answer choice B. Now that's the correct way to do it. Now, as usual, we're going to do the Desmos way, and if you've been watching these videos before, I'm mad that I can't use another program because I have to use my phone. So Desmos way can be done two different ways, but we'd start with 24 is equal to 3 to the x minus 2 power, and we just need to get a side equal to 0. So we can just subtract this side, and we have 24 minus 3 to the x minus 2 is equal to 0, but in Desmos we would type in 24 minus 3, and I think you have to put parentheses when you put them on top, is equal to y, and we're going to see what our graph looks like. So when I typed it into Desmos, I did have to get the parentheses to do that, and now here's the graph. And just like we talked in the previous lesson, you look at where it crosses the x-axis. So when we look at our beautiful graph, it has this weird little look. It crosses here, and we can press the dot, and the dot is at 4.893 comma 0. And since it's exactly 0 here, we can use that number, and hence that's the other way to get our answer. Now we'll do a couple more this way, or both ways. So once again, let's look at doing the problem the correct way first. 19 is equal to 4 to the 2x plus 5 power. So what we're going to do first, since the 4 is already isolated, we do the switch. So we have log with a base of 4 of 19 is equal to 2x plus 5. So on this problem, we're going to subtract 5 from both sides. So we'll have log base 4 of 19 minus 5 is equal to 2x. And then below, we'll have a 2 under both. So this would cancel, be left with x is equal to log base 4 of 19 minus 5 over 2. And then this is the point we just type it in the calculator. What I would do is do it as a fraction. And then alpha window 5, log base 4 of 19 minus 5, and on the bottom would be 2. And this is, obviously I don't have the right answer choice, so on your copy of this, I will make sure to fix this. So yeah, I will change this. I'm not redoing the video because I have the wrong multiple choice answers on something that you don't necessarily need to be multiple choice, but this would be negative 1.438. And here it is, answer choice E. So that's what you're supposed to do. My bad, and knowing me, there's probably going to be more mistakes like this. Maybe I should just not do multiple choice. Anyways, the Desmos way will have 19 is equal to 4 to the 2x plus 5. And then we'll subtract 4 to the 2x plus 5. And we have 19 minus 4 to the 2x plus 5 is equal to 0. But when you type it in good old Desmos, you have 19 minus 4 and in parentheses 2x plus 5 is equal to y. And I've already typed it in Desmos. I lied, I did not. Here we go, is equal to y. And so you have a weird little graph. We don't know exactly what it looks like, but it crosses here at negative 1.438, comma 0. So one more, just to hit the home run here. We'll have 25 is equal, I guess the thousandths. So we need to review what thousandths is. So like if it's one decimal place, and this is just a review of your decimal places, this would be called your nearest 10th spot. So 1 decimal place. 2 decimal places is what you call your 100th. So 3 decimal places would be what you would call your thousandths. They will count you wrong on the exam if you have the fill in the blank and you don't go as many. So we're going to talk about the way you can cheat rounding and the way you do it the way you're supposed to. But anyway, 25 equals 4 to the x minus 5 power. So we're going to switch this to a log. So this would be log with a base of 4 of 25 is equal to x minus 5. Then we'll add 5 to both sides, but need to make sure we'll have it like this, and then we'll type in a calculator. Log base 5 of 4 of 25 plus 5 would be 7. So one way to round is, since that 1, you go 3 places, so it's 3, 2, 1. This 9 is higher than 5, so that would change to a 2. If you are not a fan of rounding, we could change it to float, and since hundredths is 3 decimal places, you can change your float. Change that to 3, and now when you type it in, it will round that 3rd place for you. So your answer is 7.322 is equal to x. And if you had to type it in a blank on your exam, that's how you would type it in. Once again, with the Desmos way, we'll subtract one of the sides. So we have 25 minus 4 to the x minus 5 power is equal to 0. So in good old Desmos, we put 25 minus 4 to the x minus 5 is equal to y. And let's type it in. So there it is, typed in Desmos. So we got our fun looking graph. Crosses here, and the place where it crosses, and Desmos seems to naturally like to go to 3 decimal places. It's 7.322 comma 0. So that is the answer we get. So go ahead and try the first set of problems and then come back to the second video.